In this class, we will learn about hashing, pattern matching, trie, suffix tree, suffix array, and compression. Through this chapter, we will be able to understand the basic concept of hashing, the main algorithms that search patterns in strings, the methods of using tries, suffix trees, suffix arrays, and strings, and finally, main compression methods, run length encoding, and Huffman code. Hashing. Most file systems do not have limitation in the number of files that can be contained in a directory. Therefore, many files can exist in each of various directories. Thus, the following works are frequently performed. However, the works can cause drop in performance. In addition, they are performed based on search. What is the solution not to degrade the system performance while performing the works? Hashing is a method of directly finding a specific item by using computational operations using a search key when the item is to be searched. Regardless of data size, the data on the big O1 time can be accessed. The simplest method is to store data directly in an address table. This method is efficiency when the set of all keys, U, is small. The key K is stored in the location K of the table T. The array size is equal to the set of all keys, U. However, if the set of all keys, U, is large, practically the table T cannot be created in the computer memory. In addition, as the set of the keys stored, K, is relatively smaller than U, the memory space allocated to the table is wasted. Hash table is used when the set of the keys practically used K is smaller than the set U. Hash table needs smaller memory space than that of the direct address table. Decrease the storage space to the size of the set of the keys practically used K. The function of calculating the location where a key value, K, will be stored is called hash function. Store the data with the key value K in HK. Hash function. Correspond the set of all keys U with the locations of the table T. Reduce the index range of the table. HK is the hash of the key value K. When the two keys are placed in the same area, it is called collision. When different search keys are applied to a hash function, return hash addresses are the same. This situation is called collision. Even if the hash function distributes hash addresses evenly, collision may be inevitable as the number of data stored in the hash table increases. The solutions to collision are chaining and open addressing. Chaining is the method of enabling the data with one or more key values to be stored in each bucket by changing the structure of the hash table. Linked list is utilized for storing multiple key values in a bucket. If collision occurs because there is no empty space at the address calculated by the hash function, investigate whether empty space exists at the next space. If there is an empty space, store the item for the search key. If there is no empty space, repeat searches until an empty space appears. Like the figure, key values from K1 to K6 are consecutively inserted. As collision does not occur in the key values from K1 to K4, store them in the table. As K5 is collided with K3, store it in the next empty space. If collision occurs during investigation, repeat searches until an empty space appears.